Picking up where we left off, we have the build running, we have it all set up, we can load, we can rebuild, we can deploy, we see the video running on the device, we have device connected, we have UART login working. What we're gonna be doing today is making the source code in the repository self-contained, so whoever comes into the team only needs to install Visual Studio, Microsoft Visual Studio, and does not need to install the whole like Cypress build environment with Eclipse and toolchain and all of that. For that, we are going to need to move all the files that we rely on that are currently in Cypress into our repository. But first things first, I think right over here, I think we would rather optimize for the size, mostly because in my experience we are gonna be running out of space sooner than anything else, unless there are some really corner cases about performance, which are quite rare. But as you add more and more features, you'll find yourself needing more space sooner than you find yourself needing more CPU power. So for that, we are changing O3 to OS for the optimization for the release build. And also with that, let's introduce, where do we build the this is where we build the L file, and when we build it we can say what is the size of the stuff we are building, which would be what's that called, this is called the ARM non-EABI. Is it how it's spelled? It is how it's spelled. Size, and we're gonna format it for the Berkeley output, which is the most human readable in my point of view. And of course we're gonna be talking about the target we are building, and this is coming from ARM non-ABI, which is this path over here. So let us copy from here, Control minus to jump back to where we were before. And here we have the double quotes in case we have some spaces, which we will. And let's just build this. And also I think I want to get rid of this V option, because that's a lot of verbosity that I personally don't care much for. Yeah, that stuff at the bottom, it doesn't change ever. So let's build without the V, but I do want to see the output of the size utility, because this will be quite telling. So this is our 123.480. That's a nice size, 123.480. That's what we get when we build with the old toolchain. And let's start with moving into the newer toolchain, which would be this path over here. Needs to change to something, we'll figure out what it is. And also we need to make sure that when we change that, we change this one as well, because this will be a different version as well. And I know for a fact it's 9.3.1, but let's see where we see it from here. When we come into lib GCC ARM, there we go, that's a 9.3.1 we are talking about. Now how do we get here, using which variable? Environment variable. That's why we have the env run environment over here. And let us figure out how do we get to this community Linux GCC ARM location. It is going to be coming from here. If you take a look at that, it's Visual Studio 2022 community, and then we need to go up 2 levels, IDE and Common 7, and then go down into Linux GCC ARMS. which is what we gonna do. And again, I'm a lazy person, and copy pasting gives me both exercise of my laziness and fewer mistakes. So as I said, from here we need to get up twice, then go back down to Linux and GCC ARM. This is where our ARM GCC install path is, and as we figured out, ARM GCC version is 9.3.1, which is different from here because this one was set up by our Cypress SDK. So that's why we are overriding these ones directly in here, at least for now. I don't think we need to change anything. Well, I hope we don't need to change anything beyond that, because all our includes are coming from, no, this is include from the SDK, but the toolchain includes are all coming automatically from the path of this install. So let's just build and see what we get. Maybe make this window slightly larger so we see the output. And when we are done building with the new, we get 1, 2, 3. It was 1, 2, 3, 4, 8, 0, which means just switching to a newer, whoa, that's a huge one, to a newer toolchain gave us 1, 2, 3, 4, 8, 0 minus 1, 2, 3, 3, 4, 8, 132 bytes, which may not seem like much, but we have not changed a single line of code and we are using the same libraries, so that's something. Even if it's less than 1%. Although size is not the main reason we are switching to a newer version, I would also imagine there are some bug fixes, so there is that. With that, let us work on the SDK. So SDK, let's open another window over here. Go to our S drive for the sources, embedded pp. I will likely be reusing the SDK with some other projects, so let's have it up here in this directory, and that will be our Cypress SDK 1.3.5. and in here what we are going to have, let's go here, our fwlib, I believe 135. We're gonna be needing all of that, include and the build libraries, of course. That is not all we need from the SDK. We would also benefit from using some of the binaries. So let's do that while we are at it. Bin. For the binaries, let's see what is useful. This much. This is for the Cypress control center. Also, we are definitely using the programmer. Let's copy that as well. And this CY boot programmer is the same one as here, so we don't need to copy it twice. And the elf to image. I will not be copying the source for this, just the binary. And one other thing left, and I just know it, is that ARM GCC bin this executable CS make. I don't think we have a CS make, or at least not as easily available, so we'll just copy it to make things easier. We'll copy it into need to figure out here or here. Probably gonna be reusing that, so this is a good enough place for CS make, which may eventually be replaced with some other newer make, because I don't think this is a very current one. Let's see what it looks like. Make dash version gives us the year is 2013. Yeah, so it's not the newest, but it does the job and is good enough for now. With that, let us do the upgrade. So the SDK is now here, which means we need to say SDK is 1 up, and then it's called Cypress SDK 135. 5. This is our place which we're gonna be using for this guy over here. SDK includes, and these library paths will all need to be changed. So Control H to change it into SDK, and also we want to change all the occurrences in the current document, which is over here, which would have been Alt A. That's our 4 changes, 1, 2, 3, 4. And after that, there is one more file, which is this guy over here, that is kinda important, the script loader file, which we'll probably talk about in the next video, which is coming from over here. No, it's coming from over here. And it is this one, fx3 loader script, which will be part of this repository over here, and we are going to change that into that much. One other minor sort of detail, but I personally really do prefer to keep my code warning free at all times. That's why you see this W all in here. It is partially because of that. And I'm looking at a warning right here, which says sh link not set for section ARM EXIADX. What is it and why is it here? So first of all, what is it? This is for exception handling in the C++. And of course, C does not have exceptions. However, the toolchain, we upgraded to a newer toolchain which brings in standard libraries, and one of the standard libraries it brings in is going to be give me the GCC, this guy. This one does include some of the C++ build libraries, which do include, albeit empty, but still exception handling, I would not call subroutines, space code, I guess is the name, which includes the indices and the tables. Those two, if we look into the script, will be towards the end of our script over here. And you would ask, what the hell? I mean, we do have something in here. How is it not? Why is it complaining about that? And the complaint, there is a complicated answer to this one. So instead of boring you with that, we'll just fix it. So we are going to discard all the sections that have any information about these sorts of sections. So that one, and of course the index. So the index and that. So let me remove these ones just out of sight and go back here, save, Control B for build. This should produce the same exact binary but without the warnings. Of course, these sections will come back when we move back to C++ or forward to C++, but for now, for the pure C world, we are not using exceptions in any shape or form, and they're not gonna change anything. Those sections were empty. I verified that actually outside of this video. What else do we need? We have the binary, we have, right, we need this one over here. This is now pointing at SDK, and underneath SDK there is a bin, and that's why we have our elf to image exe. The same is also true for the other that we used for this guy, for programming. This is SDK, and then it's a bin directory, and of course while we're at it, the csmake needs to go up one level, because this is the one we are going to be using. So one up level, Alt A to replace all, save. Oh, it doesn't like the backslash. Let's fix that. I kinda had a feeling, but apparently this looks much better, because this is after all JSON, which is JavaScript, and JavaScript, just like in C, Java, C++, and all the related languages, you escape characters when defined in a string. If you begin with a slash, it's just an escape character. So // would have been a proper way to do it, but it's too verbose and it does work this way, so I prefer it here to be in that way. Anything else we need? Probably not. Let me just build, see if we can build, and while at it, let me turn on the device. Tram-parapam. We have something running here, which is our blinking LED, which is the default one. Also, let me reset the device with this button over here, and we should be seeing the loader. Come here, a bootloader. Okay. So let me wait. Why am I doing all that if we need to verify that it all works as expected? So for that, let me actually close this, close Visual Studio, go to the Cypress place, and just for now rename it into something else, so that we know that when we are building, we are really using the local repository stuff. So let's go back here, let's launch Visual Studio, and also in our repository now we have these SDK utilities that are being provided as part of our repository setup. And this is our control center, which hopefully is working properly. Nice. Now let's deploy and hope it deploys correctly. Deploy to RAM. Where is our terminal? Over here, and we have the hello world. That's the one we have, and of course we need to verify, make sure that when we run the camera, it does the video thingy, which it does. Good. Just as a matter of making sure nothing is broken, let's just do a quick build of all the types of builds we have. Going to compress the video to shorten it, because it's just a rebuild. Click, run, click, wait, click, run. And I am satisfied that everything is working properly, so we can rename this one back. Even if we are not using it anymore, I just like to get the system back into original state, so it's safe. And now we can go to GitHub, see what the mess we've created. We have our CSMake as part of the repository. We have our SDK with the binaries, with the pre-built libraries, with the include files. We have our script, loader script, modified to discard the C++ specific sections. We have our makefile adjusted to run ARM GCC from the Visual Studio install, and upgraded its version to 9.3. Made sure we are using our local copy of the binaries to do the things we want, and the tasks is also updated to use the CSMake. That means we can now say that it's season 1 episode 8, if I'm not mistaken. How do we call it? We call it self-contained source code in repo, because from here on we no longer what's the word I'm looking for, rely on having Cypress SDK installed in order to work to play with the dev kit. There we go. Commit, and took a while, and push. Oh, right, because we have quite a few executables, binaries, and all that, so the size of our commit is larger than usual today. That's what you get. And next video will probably be a much longer one, shorter depending on how it goes, but we'll be discussing what are the benefits of going into C++ versus using pure C, because there are so many people, especially the I would say people with more experience of yesteryears, they are really set on the idea that C++ is unacceptable as a language for the embedded. So we're gonna tackle that, talk about that, and with that, thank you for watching and see you in the next video.